So in using our quadratic equation, or quadratic graph rather, to find the solution of one linear, one quadratic equation is a very simple one to do. So I'm going to describe that in a plain sheet like this. Then after that, I can now the uh, plot an example and show how that can what that can give you. So how do we do that? Let's assume that you have your curve like this, or you have your curve like this. Okay, so this is your quadratic curve. Then you now have a straight line. You now have your straight line. So what you are having here is your quadratic curve, and what you have here is your linear line. Okay, so we also have that here, your linear line and your quadratic curve. So most of the problems on one linear, one quadratic simultaneous graph is going to look like this. These two graphs you are seeing here, please, they are different. So let me separate with a line. Okay. Now the question now is, how do we, or how can we get our solution from this curve? Okay. How can we get our solution from this curve? It is very simple. The solution of one linear, one quadratic equation is the value of s at the intersection between the linear line and the quadratic curve. So the solution of one linear, one quadratic equation using graphical method, okay, is going to give you the value of s. So you find the value of s at the intersection between the linear line and the quadratic curve. So where is that going to be? It's going to be here. You find the value of s at this point, find the value of s at this point. That's the two places that the linear line intersects with the quadratic curve. In this case also, you find it, let's call it point A and call this one point B. So how do you find it? Remember, here is your x-axis and here is your y-axis. So you trace it to find the value of x at this point. You also trace it and find the value of s at this point. So you can call this one your x1, you can call this one your x2. Likewise, this, you are going to trace it to find the value of your s here, trace it down to find the value of your s. You can as well call this one s1 and call this one what? S2. So that's how to find your solution of one linear, one quadratic simultaneous equation using graphical method. Then another thing we're going to look at is minimum value, maximum value, and line of symmetry. Minimum value, maximum value, and line of symmetry. So when you have a curve of this nature, now, okay, let's make it two so that we can both explain. So this one here will give you your minimum value, okay, and this one here will give you your maximum value. So first thing we need to notice in this curve is that there's a turning point here, and there is also a turning point here. So the turning point is what is going to give you your minimum and the maximum value. So at that spot, that's where you are going to have your minimum and maximum value. So what can we conclude from that? The minimum or maximum value is the value of y at the turning point. So in this case, when you trace this and find this value here, it becomes your maximum value. And here, when you also do the same, this one will give you your minimum value. So that's how to get your minimum and the maximum value. Then when it comes to line of symmetry, we also use the same uh, turning point in finding our line of symmetry. So line of symmetry is the value of s at the turning point. So the value of s at this point, so you can see the turning point there. So here is your line of symmetry. This one also, that will give you your line of symmetry. So here is your line of symmetry, and here will also give you your line of symmetry. So that's how to get your line of symmetry, your minimum value and your maximum value. So the next one now we are going to look at is how to find the value of x at a given point of y, or how to find the value of y at a given point on x. So let us describe that before we solve an example. So let's take something like this, and let's have another one. Okay, so we are going to describe when s, find the value of s at a given point of y and find the value of y at a given point. But let me describe the second one first, to find the value of y at a given point of s. So let's assume that I have -1 here, 0 here, 1 here, 2 here, 3 here. Okay, and I have -1, -2, -3, 1, let's go here 1, 2. So the same thing here, let's go here -1, -2, 1, 2, 1, 2, -1. Okay, now how do we get the value of s at a given point of y? Let's assume that we are giving s as 2 and ask us to find the value of y. What are we going to do? That one is very simple. All you need to do is go to s equals to 2. Of course, this is your s value. So this s equals to 2. Trace this s that is equal to 2 till it meets the what? The curve, until it meets the curve. So when it meets the curve, you now find the value of y at that curve. So here is the y. So you find the value of y at that curve. Okay, so that's how to find that. So you trace from your x, meet the curve, then find the value of y from that point. Then when you are asked to find the value of s at a given point of y, let's say at y equals to 2, you are looking for x. So in this case, whenever you are given y and you are asked to find the value of s, we are always likely to have two values of x. Okay, because there is always two values of s that will give you a certain value of y, unless it is at the turning point. It is only at the turning point that we have only one value of uh, x at that particular given point of y. So in this case, 1 is not the turning point. So if I'm asked to find the value of x at y equals to 1, I will draw a straight line that passes through 1, okay, parallel to the x-axis. Now, the point that that straight line meets the curve, that's the point that I'm looking for. Okay, that's the point that I'm looking for. So all I need to do is to trace it down and find the value here, trace it down and find the value here. So that will give me the s value that I'm looking for. So after describing these things, so let us look at an example and apply it in our graph and see how we can be able to find that. Let us look at this example here. We are asked to copy and complete the, the table the table of value for the relation y equals to 2s squared plus s minus 2 for minus 3 less than equals to s less than equals to 2. And we are asked to plot a graph. We are given scale and we are asked to use our graph to find the root of the equation. Of course, they always ask this one. Then to find the root of an equation. Okay, so I will talk about it when we get to this point. To find the equation for the line of symmetry, to find the minimum value, and to find the value of y at s equals to minus 2. So let us first of all take care of a question, which is the table of value. Now, in this table of value, I'm going to use the method that I described in one of my videos. Which method is that? Is a method that helps us to plot our curve very smoothly by inserting a number between these two numbers, each of the two numbers that I have here. What does that mean? Between minus 3 and minus 2, I will insert a middle value. Between minus 2 and 1, I will insert a middle value. So what we normally insert is just to add 0.5 to it. The essence is that it makes our graph easier for us to plot, for us to have a very smooth curve. So let us create that modified table that we are going to insert numbers between what is given to us. We are done filling our table of values. Remember, the equation is y equals to 2s squared plus s minus 2. Now that we are done with the table, the next thing is to go and plot our graph. So let us go and plot our graph. We have already described how to plot quadratic graph, so you can actually check it out. I have about 2 videos that explain how to plot quadratic graph, so you can look at it and plot this by yourself as I plot mine. In labeling my graph, I have to consider the scale: 2 cm to 1 unit on x-axis and 2 cm to 5 units on y-axis. So as you can see, I'm done with my labeling of graph. So the next thing is to plot the points on the table of values. So at -3, I have 13. At -3, I have 13. So here is 10, 10.5, 11, 11.5, 12, 12.5, 13. So remember, we have done quadratic curve. So you can check it out and see what I mean by what all these things that I'm doing. So at minus 2.5, you have it as 8. So here is 5, 5.5, 6, 6.57, 7.58. So which is at this point. Okay. So at -2 is 4. So if I count like that, I'll get my 4 at this point. -1, oh, we need to get minus 1.5. So -1.5, which is middle of -1 and -2, I will have 1. So I have 5, 0.5, 1. So which is there. Then at -1 is -1. So 0.5 minus 1. So which is here. So I'm counting down, not because of -1 here, because if I count down, it will give me this point. Then at 0.5 is -2. So here is minus 0.5. So I'll now count for y-axis. -0.5 minus 1 minus 1.5 minus 2. So -2 will give me here. So at 0 is the same -2, so which is on the same value of y. Then at 0.5 is -1. So that will give me at this point. At 1 is 1. So I'll come up here. At 2, oh, I can't do 2. I'll have to first of all do 1.5. So 1.5, which is at the middle between 1 and 2, will be 4. So which is here. And at 2, 2 will give me 8. So 8, this is 5. 5.5, 6, 6.57, 7.58. So which, so you can see our curve. Okay, so our curve is about being ready. So let us join the line. Remember, my hand inside the curve. So because I have all these middle points, it makes the points to be closer, so helping me to get my curve easily. So I'll have it like this. You can make it fat first before making it thick. So you can see my curve. So you can see how smooth that curve is. So the next thing now is to go back to our questions and answer the questions there. The first thing to do is to find the root of the equation. We know that the root of the equation is the value of x at y equal to 0, or the value of s where the curve cuts the y-axis. So when you look at this curve very well, you will notice that at this point and at this point is where our root of equation is. So I don't want to write on the graph so that I can be able to have space to find all these other equations. So our CI, our question CI, if I trace this very well, I can count this 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So S equals to 0.8 and S equals to, let's count the other side. Here is already -1. Okay. So we have minus 1.1, minus 1.2, and minus 1.3. So I have minus 1.3. So that's the root of our equation. The next thing now is to solve an equation. Now the second equation given to us there, which is in solving for root of the equation, is very simple for the quadratic. Now you can see that in this equation of we are asked to find the root of 2s squared plus 3s minus 6 equals to 0. Like I said, the the simultaneous equation, they will not, give you the two equations. Rather, they will merge the two equations together so that you can use it, and or so that you can be able to split it by yourself and solve the simultaneous equation of using your graph. So this problem here is simultaneous equation graph, because you can see the graph given to us, which is 2s minus 2, and you can see the one that is there we are asked to find, which is 2s squared plus 3s minus 6. So what are we going to do? What to do is very simple. Whenever you are given a problem like this, you plotted an equation and it looks as if that an equation is given to you to find the roots. So all you need to do is to, which is 2s squared plus s minus 2, subtract or minus what you are asked to find. That is not what you plotted. That's 2s squared plus 3s minus 6. So when you subtract, x minus 3s will give you minus 2s, minus 2 minus minus 6 will give you plus 4. So this is the resulting linear expression. This is what we are going to plot. We are going to plot y equals to minus 2s plus 4. So this is the quadratic and this is the linear. When we match them together, we are going to have what we have plotted here. Okay, we are going to get what we have plotted here. So let us find the values now. The way we plotted linear equation last time. So we say at y equals to 0, s, so when you make y equal to 0 here, s equals to 2, and at s equals to 0, when you make s equals to 0, y equals to 4. So we are going to use this now. We are going to use this and plot our straight line. Now, coming to our graph, when s equals to 2, which is at this point, okay, which is at this point, then we need to find the corresponding value when s equals to 0, which will give you y equals to 4. So when y equals to 4 there is here, s equals to 0, y equals to 4. So we are getting those 2 points. So with those 2 points now, we use our straight ruler and draw our straight line passing through those 2 points. So that's the straight line. Now you can see the graph of simultaneous equation, one linear, one quadratic simultaneous equation. If you remember, this is our linear line, this is our quadratic. So if you check the kind of graph that we have now, so we have that this is our quadratic and this is our linear. Okay, so these two graphs together is going to give me the equation I'm asked to find in CII, which is this. Okay, so we need to find the value at the point of intersection and at the point of intersection here. So we need to find the value of x. So let us do that. So at this point, which is between 1.1 and 1.2. So we can take it as 1.15 since it's between 1.1 and 1.2. Now the other one is there also at the middle. So let's count. This is minus 2, minus 2.1, minus 2.2, minus 2.3, minus 2.4, minus 2.5, between minus 2.5 and minus 2.6. So we can take it as minus 2.55. So that's the solution of that simultaneous equation, one linear, one quadratic, which they do not pronounce that is actually one linear, one quadratic, but when you solve it like one linear, one quadratic expression. Okay. Now the next question we have there is line of symmetry. So that's our I. So line of symmetry. Line of symmetry, you find at the point, the lowest point of the graph. Okay. So we are going to find both the minimum value and line of symmetry at the same time. So you can see that this is where the where the curve turns. Okay. So the turning point here is minus 2, here is minus 2.5. So we can take it as minus 2.2 or minus 2.3. Then for x value, here is 0, 0.1, 0.2, 0.3. So it can also be 0.2 or 0.3. So from what I can see there, I have my line of symmetry as s equals to 0 minus 0.2. So you can also take it as minus 0.25. Okay. So how do we get that? The turning point, you find the value of x. Then for minimum value, you also find the value here. So we count 5 minus 0.5 minus 0.1 minus 1.5 minus 2 is not up to minus 2.5. So I can say that y equals to minus 2 point, let's say 2 is the minimum value. This one here is the line of symmetry. Okay, so the last question we have there is that we are asked to find the value of y. We are asked to find the value of y when s equals to minus 2. So it's also very simple. So if you go to our graph, when s equals to minus 2 is at this point, and the value is even in the table. If you check our table, is there in the table. So when s equals to minus 2, y equals to what? 4. So you can just write it out that at s equals to minus 2, y equals to 4. So you can also check it here. This is your x. So you count 0.51, 1.52, 2.53, 3.54. So that's how we got our y equals to 4. Okay, so that's where we are going to conclude this video or this class.